Hello, welcome to another video of heuristic algorithms. In this case, we're going to discuss how to compute a numerical derivative. And for that purpose, I have created here an example in which our function is of x is y equals to 4 times x squared minus 3 times x plus 5. And from your calculus classes, we know that the derivative with respect to x, of the derivative of y with respect to x, would be a times x minus 3. So we can find the value of that derivative. We can find the value of the function simply by stating that function here in the cell in Excel. We have x squared times 4 minus 3 times x plus 5. And the derivative in a numerical way would be equivalent to a times the value of x minus 3. Of course, that would be just replacing the number under the analytical solution for the derivative. That's not what we're intending to do. What we intend to do here is to actually compute the numerical value as an approximation. And if we remember our definition of a derivative, we have that f prime of x is equal to f of x plus h minus f of x, all that divided by h, as long as we compute the limit of that when h is a very, very small quantity, when it's h tends to 0. So that's the definition, and that's what we're going to do. We're going to compute the derivative in that sense. So the numerical derivative would, for that purpose, would have to be, we need to define the value of h, and let's say that I define h is equal to, we need a very small value, 0.00, is that's 1/10 of a million. Okay, so that's going to be our value. We can compute x plus h here, and we have x plus h, and that formula we can use for all our domain, and with that we can compute now f of x plus h as the square of x times 4 plus or minus 3 times the value of x plus h plus 5. Of course, that's not going to make any difference for the values. It's not going to make a big difference. Okay, this is going to be f of x plus h. Okay, and it looks like it's the same number, but if we go to the details, it's not exactly the same number. This is 5, this is very close to 5, but not exactly 5. So we can compute those same values for f of x plus h, and now we can compute the derivative as this would be the numerical derivative, or f prime, well, let's say just d of, it's just an approximation, is the difference between f of x plus h minus f of x, all that divided by h. And there you go. The number again is not the same, but it's pretty close. So we can compare the values in this column in yellow with these values of this column in yellow. They are pretty close, and that's how you do it. We would like to be able, now we could do this of course using Visual Basic, and that should be very easy to do. Thank you.